Thank you for watching these quadratic functions again, and welcome back. Today we are going to dive deep, and first we are going to try to put the function on this in this format here. Here h and k are the coordinate of the vertex. Vertex has h and k. Okay, and if you look at the line here, this axis of symmetry, it has an equation of x is equal to h. This is what we are going to calculate and show how to get h and k. That will help us in the future on how to graph these functions. Okay, if we look at a quadratic function, fx is equal to ax squared plus bx plus c. Let's try to do some factoring here. We can say it is equal to a factoring x squared plus b over a x, and we isolate the c, please. Okay, and we can also say that x squared plus b over a x is of the form a squared plus 2ab, and we know that a squared plus 2ab is equal to a plus b squared minus b squared, correct? So let's apply that here. We can say then fx is equal to a factoring x plus b over 2a squared minus b over 2a squared. That is the first part here. Now plus c, correct? We have to close this one here. That gives a factoring x plus b over 2a squared minus a times b squared over 4a squared, then plus c, correct? Let's put simplify here, and then we get another form. We can then say that f of x is equal to a factoring x plus b over 2a squared plus 4ac minus b squared over 4a. Okay, that is what we are looking for. If you look at that part here, that is minus h, and this is k. That means our f of x is equal to a factor x minus h squared plus k. This is what we are getting. And for our conclusion here, we can say that h is equal to negative b over 2a, and k is equal to 4ac minus b squared over 4a. So the vertex can be found when we find these 2 points. Okay, and the axis of symmetry, let's see here. The axis of symmetry we can say x is equal to h, or x is equal to minus b over 2a. This is a vertical line in our situation here. So that's what I wanted to bring your attention today, but we are going to proceed and try to apply this first with the function we have, and then try to use it to solve other problems. Okay, Now let's get a function here. We are going to take a picture here, x squared plus 6x plus 5. We can clearly say that we can say 1x squared, so a is equal to 1, b is equal to 6, and c is equal to 5. Definitely h is equal to minus b minus 6 over 2a over 2 times 1 is equal to negative 3, and k is equal to 4 times 1 times c is 5 minus b squared 6 squared over 4a, 4 times 1, so that gives us 20 minus 36 over 4. That makes it minus 16 over 4. That is equal to negative 4. So that function can be written as a is equal to 1 factoring x minus h is equal to negative 3 minus 3 is 3 squared, and then plus k is negative 4, so minus 4. Finally we can say that x squared plus 6x plus 5 is equal to x plus 3 squared minus 4. Okay, but you don't have to remember these formulas. In practice, when you give me this equation like x squared plus 6x plus 5, all I need to do is to look at the 6 divided by 2, that is 3, so I say x plus 3 squared minus 3 squared, now plus 5, which is equal to x plus 3 squared minus 4 minus 9 plus 5. So we have the same result. So in practice we don't remember these formulas, but we have to know how to break it to know that this form is equal to of the form a squared plus 2 times a times b. Okay, and of course we can see here that in this situation here the axis of symmetry has for equation x is equal to h is equal to negative 3, and then the vertex is at hk negative 3, no, hk negative 3 and negative 4. So if we scroll up and look at the curve we have, we can see that that's what we have here. If you look here, this is 0. We can see that this is x is equal to h. Let me change the color here. Becomes x is equal to negative 3, that is axis of symmetry, and the vertex is equal at negative 3, negative 4. Okay, so that's what I wanted to bring up today. I'm going to dive deeper later and show you more examples of this, and this is what we are going to use to try to sketch most complicated functions. Okay, thank you for watching, and see you on the next video on this. See you.